first of all, what does that word regress mean? Regression, or if you regress, what are you doing? Going down or going backward, right? Okay. So regression means to go backward. So linear regression means we are going to go backward to write equations of line. Okay, so we're going to be given some data. Okay, we'll be given some information, whether it's a list of ordered pairs or a table of values. And we're going to use that data to come up with a linear equation that would create the line of best fit for that data. Okay, so some of those terms like line of best fit will sound familiar from previous math classes. On this first page of the notes, you've got two boxes. You've got the regression steps using a TI-83 or TI-84 if you have a graphing calculator of your own. We do not have a class set of these, so we're not going to be going through this process. But here are the steps if you do have your own calculator, and that's what you prefer to use over Desmos. Now, the next box are the Desmos steps. So what I would like everybody to do, I know we don't normally don't have our laptops out during notes. I would like you to get them out and go to Desmos, because as we go through these examples, I want you following along and practicing these steps in Desmos. Okay, so everybody take a minute and get your computer turned on and logged in and go to Desmos, to the graphing calculator in Desmos. Okay, and then I'll show you these steps in Desmos. Okay, I think it's going to be easiest. I tried to just talk through the steps before looking at an example with my other class, but it doesn't really make much sense unless I'm actually inputting data. So I'm going to read the first example here on the next page, and then I'm going to go through these steps using this information. Okay, it'll make a lot more sense, I think, to see it in action with actual data. Okay, so I'll come back to those steps in just a second. While y'all are getting logged in and to Desmos, I'm just going to read through this first problem. It says the number of newly reported crime cases in a county in New York State is shown in the accompanying table, where X represents, I'm just going to do some color coding. Okay, so X represents the number of years since 2004. Okay, so if it's been 0 years since 2004, what year is it? That is 2004. So the data starts in 2004. And then it's 2005, 6, 7, etc. Okay, so X is the years since 2004. Okay, and the Y column is, it represents the number of new cases. Okay, so the number of new crime cases reported is our Y column. We want to write a linear regression equation that represents the data set, and we're going to, it says to round to the nearest hundredth. Now, I'll show you in the calculator in Desmos when we input the data. Sometimes you won't need to round because it'll automatically truncate itself, but sometimes you will. So you do have to pay attention to what your instructions say to round to. Okay, and then we're going to use that equation to find the projected numbers of new cases in 2014. Now, before I even jump into inputting that data, we just said that X is the number of years since 2004. So in 2014, what is my X value going to be? How many years since 2004 is 2014? 10 years. So I'm just going to go ahead and mark that. So we know what they mean when they say in 2004, they're telling us our X is going to be 10. So once we come up with our equation using linear regression, we're going to use that equation and we're going to plug in a 10 for X and predict the number of new cases. We're going to find Y. Okay. Now, when we write a linear equation, what is the format that we're used to seeing for a linear equation? We've been using it some when we were doing like mx plus b. Very good. mx plus b is the form that we're going to write our linear regression equation in. And we have to remember, ooh, I don't know why it keeps zooming in and out on me. We have to remember what m and b stand for. What is the m? M is the slope, good. And b is the y-intercept, very good. Okay, so I have to remember those things before I can come up with my equation. All right, so what I'm going to do, I'm going to split screen this here with my calculator, and I'm going to use this data right here from this table, and I'm going to go through these steps on the first page. So the first step is to enter your data. To do that, you're going to click the plus sign here in the top left corner, okay, and you're going to input a table. So click the plus sign and then click the table, and this is what you should get. Now you're going to enter your X values and your Y values. Okay, so from this table here, I'm going to enter this data. So I've got 0, 1, 2, 3. And for my Y's, got 1,077, 1,041, 1,076, and 1,004. So I enter my data. Now, in your graph is probably here, 10 by 10, positive 10 to negative 10. And so you don't see anything because look how big these numbers are. These are huge. So if you want to scroll out to see, your graph is actually plotting those points. As you put in a table, your graph is going to be coming up with those points graphed. Okay, it's creating a scatter plot of that data. Okay, now this one, I have to be way zoomed out to see it since they're such large numbers. But I want you to know when you put in a table, the data does appear as a scatter plot. Okay, so you get a scatter plot over here. Okay, now the next thing we want to do, once we have that data entered, we're going to calculate the regression equation. Now to do this, this one says click the plus and click expression. We don't actually need to do that. We can just click down here into the second blank. If you do that, if you do the plus expression, all it does is add another line here for an equation. Okay, so really you don't really need that step. You just click down here into the second blank. Okay, now in this second blank, it is very important that we type this exactly as we see it. Okay, right here is what we're typing. But we have to make sure, I'm going to highlight a few things here. We have to make sure that my highlighter here, we have to use this tilde, I think it's called, this tilde symbol. Okay. We do not use an equal sign. If you use an equal sign instead of that symbol, it's not going to work. Okay, so we have to make sure we're using that tilde symbol, and I'm going to show you where you can find that. And we have to make sure that we are typing in X1 and Y1. Okay, not just Y and not just X. You've got to type a 1 after it. Now, when you do that, so make sure to type the 1 after the variables. Okay, when you do that, it will automatically make it a subscript. Okay, so I'm going to come over here and do this typing. So I'm just going to type Y, and then when I do 1, look, it automatically made it a subscript. It knew when I type Y1 that that's what I want. Now I'm not going to push equal. I need that tilde. On your keyboard in Desmos, if you open up your keyboard, you'll hit this ABC button, and then it's down here, bottom row on the rightish side. Okay, so if you click there, you'll get that tilde symbol. Okay, and then I'm going to go back. Now I'm going to type in M and then X1 and then plus B, because that is linear. So that's the form I want. And it has automatically graphed that line of best fit through our scatter plot. Now the equation of that line of best fit, it doesn't just straight up give me the equation, but it does give me my parameters, which is m, which is the slope, and b, which is the y-intercept. So now I can write my equation using that m and b value. Okay, so they gave us m and b here. So I'm going to come back to this example, and I'm going to write we came up with. All right, so they came up with the slope is negative 18.4. Now this is what I was referring to when I said sometimes you won't have to round, because they just told us 18.4. It said to round to the nearest hundredth up here. This is already to the 10th. I have no hundredth, so this is fine. Okay, so I'm just going to leave it as a negative 18.4. And then my B, my y-intercept, is 1,077. 1 sec, I don't know why that dot is there. Here we go. 1,077.1. Okay, so now I can use that information and write my regression equation. So I'm going to say y equals negative 18.4x plus 1,077.1. So far, so good? So it's just making sure you can follow those steps. We haven't had to calculate anything yet. It was entering data and making sure that we typed the mx plus b in this correct format there very carefully. And that gave us our m and our b. So we have to know m is slope and b is y-intercept, and we can write our equation. Now it does have a question. It doesn't say just write the equation. It says now find the projected number of new cases for 2014. And we said that that meant X was 10. So now I'm going to plug in a 10 for X. I do not have to calculate this by hand. We can go back to Desmos over here and type that in. So I'm going to come to this next line and I'm going to do negative 18.4 times 10 plus 1,077.1. So I get 893.1. But what does it say here to round this to? It says to the nearest whole number. Okay, so is that 0.1 going to round this 3 up? Is this closer to 893 or 894? 893. The 0.1 does not round it up. Remember, it has to be a 5 or higher in the next place value to round it up. So this, for my final answer, I'm going to say 893, and this unit in this case is new cases. That is the projected number of new cases in 2014 if this data trend continues. All right, so we're going to go through this process here again, where we enter data, we come up with our regression model, okay, and then we can use that regression model to make predictions. Everybody feel okay about that? All right, so in this one, our data is representing homework grade versus test grade for a math class. Okay, it says the teacher wants to see the correlation between test scores and homework. Okay, so X is the homework grade, Y is the test grade. Okay, we want to come up with a linear regression equation that represents this data, rounding all coefficients to the nearest 10th, and then use it to find the projected test grade to the nearest integer for a student with a homework grade of 69. Okay, so first we have to enter our data. Okay, so I'm going to go back to Desmos. I want y'all going to Desmos on your own and practicing these steps. Make sure yours looks the same as mine. If you're getting something different, you're typing something wrong. Okay, so again, add table, and then I'm going to enter the data. Okay, so this is, sometimes it's easy to make mistakes when you're entering data, especially if you're trying to do it quickly. So if y'all see me make a typo or a mistake, y'all call me out. Okay, so there's my X column, and then my Y column. Excuse me. Thank you. All right, so my data is entered. So now I'm going to go to the next blank under it, and I'm going to type what? What do I type here? Y1. Okay, and then the tilde. Now, I'm going to show you one other way to get that. I showed you here on the Desmos, if you hit the ABC button, it's down here. On your actual keyboard, let me see. I know where it is. I'm trying to get my camera. Here we go. So I can show you my keyboard. Oh. Okay, so this is the right way. Okay, so here is my keyboard. Okay, it's up here near the 1. See, that's the tilde. So because it's up top on that key, you have to hold shift. So I'm going to hold shift and then hit this button, and that gives me the tilde. Okay, so you can do it on your keyboard. Let me close my camera. Okay, again, you hold shift and enter that button. So it's up there in the left corner next to the 1 on your actual keyboard if you want to use it there. Okay, so Y1 tilde and then X1 plus B. So when I finish typing that in, I get my data that it gives me here, the parameters to write my equation. Go. Just happened. There we go. Sorry, it disappeared on me. So now I'm going to come over here and I'm going to identify, okay, we got equation is oops. Yeah. Y equals, now it said to round these values to the nearest 10th. Okay, so looking over here, now this one I do need to round. Okay, it's 0.8 is in the 10th place, but remember you always look to the next number. So is the 2 going to round that 8 up? No, so this is going to be 0.8 for my M. X. And then my B is positive, so it'll be plus. But when I come over here to round, the 8 is in the 10th place, but I look to the right. Is that 5 going to round it up? Yes. So this time it does round up, so it's going to be 6.9. So there's my linear regression equation. And now they want me to use it to predict. What are we predicting this time? Yeah, when the test grade, so predict the test grade when the homework grade of 69 scooch over. Okay, find the projected test grade. Okay, so they want us to plug in a 69 for what? For X. Good. So when X is 69, what is Y? That's what the question is asking. So we're going to come down here and plug that in. And then I'm going to type it in Desmos. I'm going to come back over here to Desmos, to the next line, and type in 0.8 times 69 plus 6.9. So 62.1. But what does it want me to round? Pay close attention to the wording on your questions because they tell you what to round everything to. This one is rounded to the nearest integer. So that's another way of saying the nearest whole number. Okay. So what is that? What's 62.1 closest to? 62. So our predicted test grade for someone who made a 69 on the homework is a 62. So do y'all get how we're using the data to make predictions? Okay, so you got to come up with the equation first, and then you can use it to make predictions. Now, the other thing we have to do, we're not going to have to enter any more data in the notes because we're going to be given this data, but they've already calculated the equation for the line of best fit. So this time, the data is given in the scatter plot, the line of best fit is already drawn, and the equation given. We just have to interpret what this means in the scenario. So it tells us that this is a scatter plot of time spent texting on the x-axis versus time spent exercising on the y-axis in a week. So over a week, time spent texting versus time spent exercising, both are in hours. Okay. They give us the equation and they ask us to identify the y-intercept. So what part of this equation is the y-intercept? Remember up here we said the format is y equals mx plus b, and the y-intercept is what? The b. So we're looking here, what is the b value? The 8.64, and it's positive. So positive 8.64 is my y-intercept. So I have to be able to identify that. And then they ask, what does this intercept represent? Okay, so you can see the intercept in the equation. If you wanted to extend the line of best fit, it would put your intercept about here, which looks at about 8.64, right? Okay. What does that mean in this scenario, though? With what the x and y represent, what does this 8.64 tell us? Let's think about y-intercept in general. A y-intercept is where you cross the y-axis, right? Okay, if I am on the y-axis, what is my x value? If I'm plotting this point here, what are the actual coordinates of the point? The x is 0, isn't it? You went over 0 and then up 8.64. So if the y-intercept is telling us the y value, which is time spent exercising, when x, which is time spent texting, is 0. So in this scenario, this y-intercept represents the amount of time spent exercising when, I'm not going to put when 0 time is spent texting. Y'all follow that? Because it's an ordered pair. If your y-intercept is when x is 0. So x is time texting and y is time exercising. So that's what it would interpret in this scenario. Feel okay about that? So we've got to be able to do three things with this linear regression stuff. We've got to be able to use the data to write an equation. So we've got to come up with the equation of our line of best fit. We have got to be able to use that equation to make predictions. And we have to be able to interpret things from that line of best fit or from that equation. So we have to do the regression, come up with our equation, we have to make predictions, and we have to interpret. So in this last one, we're given data. It says this is the cost of the visit of a plumber. Okay, this is the length of the visit versus the cost of the visit. Okay, it says that the plumber charges a flat fee for visiting the house or apartment and an hourly rate. Okay, so there's a flat fee for him just showing up, and then it depends on his hourly, how long it takes him. Okay, so they've already come up with the equation. We don't have to enter this in Desmos. It's already done. We have the equation. So this is, if the hours is X, the total price is Y. It says, what does the y-intercept represent? Well, what is the y-intercept? What's the y-intercept here in this equation? I'm sorry? Right, but what's the value? What number? In this equation, is it the 18.60 or the 79? The 79, that's my y-intercept. Remember, it's mx plus b. Okay, if you need to write that, mx plus b. B is the y-intercept. Okay, so 79 is my y-intercept, and what I just heard is what it represents. In this scenario, that represents if 0 time is spent working, because if X is 0, so there's no hourly cost, you're still paying $79. So that represents his flat fee. Okay, the flat fee for just visiting is what that represents. Okay, so $79 flat fee for the visit. That's what it represents in this case. Y'all feel okay about this? All right, so you're going to keep your laptops out because you're going to use Desmos to answer some of the practice questions in Delta Math. Okay, so you've got a short Delta Math practice. Some of them are entering data and coming up with equations. Some of them are making predictions. Thank you. And some of them are just interpreting. Okay, so it's a little bit of each of those practice from these notes. Okay, so I'm going to go and activate that for you now.